in group theory, I already discussed what is algebraic structure, what is semi-group, monoarray group, abelian group, what is finite group, how to find order of an element, also how to find order of a group. Today I will discuss subgroup. Let G be a group, a subset H of G is called subgroup of G if H is a group with respect to star. Means if G is a group with respect to this binary operation, then H must be a group with respect to this same binary operation and H should be subset of G. The identity element and group itself called the trivial subgroup and the other subgroup without the trivial subgroup called the proper subgroup. And if G is abelian, means a group with commutative property, then its subgroup is also abelian, means subgroup also have the commutative property. Let's see one example. Example 17. Let G contain 1 minus 1 I minus I is a group with respect to multiplication. Then H equals to 1 minus 1 is a proper subgroup. Next, Lagrange's theorem. This is important. Lots of questions asked from this. So for any finite group, say G, the order of subgroup H of group G divide the order of G. Means H order should be divisible by order of G. And the order of a group is number of elements in that group. And it was developed by Joseph Louis Lagrange. Hence, it's called as Lagrange's theorem. So, the order of subgroup should be divisible by the order of group. Now, example 18, G contains 0, 1, 2, 3, 4, 5 is a group with respect to addition module 6. Which of the following subset of G are subgroup of G? And 4 options are given. We need to check which one is the subgroup. Now, H1, 0, 3. Just check 0, 3 and this is addition module 6. Now 0 plus 0, 0, 0 plus 3, 3, 3 plus 0, 3, 3 plus 3, 6, 6 divided 6, it's 0. It's a subgroup. Now check H2, it's 0, 5, 0, 5. 0 plus 0, 0, 0 plus 5, 5, 5 plus 0, 5, 5 plus 5, 10, 10 divided by 6, remainder will be 4. It's not closure. It's out of this 0, 5 set. Hence, this is not a subgroup. Now check S3, 0, 2, 4. Now 0, 2, 4. Then 2 plus 0, 2. 2 plus 2, 4. 2 plus 4, 6. Here it will be 0. 4 plus 0, 4. 4 plus 2, 6. 6 divided 6. Remainder will be 0. 4 plus 4, 8. 8 divided 6. Remainder will be 2. Its closure, hence it is a group. Its closure also addition module is associative. It also have the identity and inverse. Hence it is a group. Now H4, order of H4 is 4 and order of group is 6. So 4 is not divisible of 6. Hence H4 is not a group. So order 2, order 3 can be subgroup, but order 4 cannot be subgroup as 4 is not divisible by 6. So here we found option A and option C are subgroup, while option B is not subgroup as it is not closure, and option D is not subgroup as 4 is not divisible by 6. So order of subgroup should be divisible by order of group according to Lagrange's theorem. Next, example 19, G contain 1, 2, 3, 4, 5, 6 is a group with respect to multiplication module 7. Which of the following are subgroup of G? Here also 4 options are given. Now first H1 is 1, 3. Just check 1, 3. Here multiplication module 7. Here 1, 3. Now 1 multiplication 1, 1. 1 multiplication 3, 3. So 3 into 1, 3. 3 into 3, 9. 9 divided 7. Remainder will be 2. It's not closure. Hence it is not a subgroup. Now H2 contain 1, 6. So 1, 6, then 6 into 1, 6. 6 into 6, 36. Now 36 divided 7, remainder is 1. It is closure. Also it is associative. It have the identity element. Identity is 1. Also it have the inverse. For 1, inverse is 1. For 6, inverse is 6. Next option C, S3. S3 contain 1, 2, 4. 1, 2, 4. Here 1, 2, 4. Now 1 multiplication 1, 1. 1 into 2, 2. 1 into 4, 4. 2 into 1, 2. 2 into 2, 4. 2 into 4, 8. 8 divided 7. Remainder is 1. Next 4 into 1, 4. 4 into 2, 8. 8 divided 7. Remainder is 1. 4 into 4, 16. 16 divided 7. Remainder is 2. So this is closure as all elements are 1, 2 and 4. It is also associative. It have the identity element. Identity is 1. It have the inverse. Hence it is a group. Next H4 1, 3, 5. Now 1, 3, 5. Here also 1, 3, 5. 1 into 1, 1, 3, 5. 3 into 1, 3. 3 into 3, 9. 9 divided 7. Remainder is 2. 3 into 5, 15. 15 divided 7. Remainder is 1. It is not closure. You can clearly see we got 2. So we found option A and option D are not subgroup as they are not closure, while option B and option C are subgroup. Next example 20. G equals to 1, 3, 5, 7 is a group with respect to multiplication model 8. Which of the following are subgroup of G, and 4 options are given. So here group order is 4 and 4 is not divisible by 3, hence option D rule out, as 3 is not divisible by 4. So we need to just check option A, option B, option C, as all order are 2 and 2 is divisible by 4. Now H1 1, 3, here 1, 3, multiplication model 8, it will be 1, 3, 3, 3 into 3, 9, 9 divided 8, remainder is 1. Its closure, it's also associative, it have the identity, identity is 1. It also have the inverse. For 1, inverse is 1. For 3, inverse is 3. Next we'll check 1, 5. Now 1 into 1, 1. 1 into 5, 5. 5 into 1, 5. 5 into 5, 25. 25 divide 8. Remainder will be 1. It is closure, associative. It have the identity, also inverse. Hence this is a group. Next check option C, S3. 1, 7. Here also 1, 7. 1 into 1, 1. 1 into 7, 7. 7 into 1, 7. 7 multiplication 7, 49. 49 divide 8. Remainder is 1. It is closure, associative. It have the identity 1. Also for 1, inverse is 1. For 7, inverse is 7. Hence it is a group. Next option D, H4 contain 1, 3, 5. Here order of H4 is 3. 3 is not divisible by 4, hence we don't need to check it as it is not a subgroup. Intersection of two subgroup of a single group is a subgroup, but union of two subgroup may be subgroup of that group or may not be. If H1 is subgroup of H2 or H2 is subgroup of H1, then their union is a subgroup. So union may be a subgroup, may not be a subgroup. Now example 21, let G be a group of order P where P is a prime number. How many proper subgroup are possible for G, and 4 options are given. So here order of G equals to P. P is a prime number and it is asking about proper subgroup. So it contains the subgroup other than the trivial subgroup, means other than the identity element and group itself. And for P, its divisor are 1 or P itself. P itself means it's the group, 1 means it's the identity element. Hence there are 0 proper subgroup possible as P is divisible by 1 and P itself, means it can have 2 trivial subgroup but proper subgroup is 0. So here answer will be 0. In today's lecture I discussed what is subgroup with some examples, and from this Lagrange's theorem is important. So the order of subgroup should be divisible by the order of group. In next lecture I will discuss what is cyclic group. If today's lecture is helpful for you, please like, share and subscribe. Thank you.